This is a Math 2 lesson summary video for the lesson titled Striving for Independence. This is a practice understanding task. The purpose of this lesson is for students to examine independence of two events using various representations. So at the beginning of this lesson, we're given a few formulas. We are reminded that the probability of B given A equals the probability of B only if events are independent. From a previous lesson, we also learned that probability of A and B equals the probability of A times the probability of B, only if the events are independent. At the beginning of the lesson, we're also given the rule that the probability of B given A equals the probability of A and B divided by the probability of A. Now, if we look closely at this equation, we can isolate the probability of A and B and get a formula for the probability of A and B that always works, regardless of whether or not the two events are independent. So let's multiply the probability of A to both sides of the equation, and we'll get the probability of A times the probability of B given A equals the probability of A and B. So this formula for the probability of A and B only works if the events are independent. But this one will work all the time, because if the events are independent, then this would equal the probability of B. And since we're reviewing formulas, let's go ahead and remember that the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. This is the addition rule. Of the 2,000 students who attend a certain high school, 1,400 students own a cell phone. 1,000 own a tablet, and 800 have both. Create a Venn diagram model for this situation. So I've started with my two circles, one for cell phones, one for tablets. And I'm going to start with what's in the middle, because 800 students have both. Now we know that there are a total of 1,400 students that own a cell phone. 800 have already been accounted for, so that means that 600 must own a cell phone and not a tablet. Since there are 1,000 that own a tablet and 800 have already been accounted for, that means 200 must own a tablet without a cell phone. And then since we have 600 plus 800 plus 200, so we have 1,600 students, 1,600 students represented here, that means there has to be 400 students left, so that way we can have a total of 2,000 students who attend the high school. So 400 students do not have a cell phone and they do not have a tablet. So even though we're only asked to make a Venn diagram to represent this situation, let's take a quick look at what a table would look like and then a tree diagram. For the table, we have tablet or no tablet and cell phone or no cell phone. So we're given that there are 800 students that have both a cell phone and a tablet, and 1,400 students that have a cell phone, and 1,000 students that have a tablet. Then we can easily fill in the rest of the table by taking 1,400 and subtracting 800 to get this 600, taking this 1,000, subtracting the 800 to get the 200, and then continuing to fill the rest of the table. For the tree diagram, I chose to start off with tablet versus no tablet. So 1,000 students with a tablet and 1,000 students without. Of those 1,000 students that have a tablet, 800 have a cell phone and 200 do not. Of the 1,000 students who do not have a tablet, 600 students have a cell phone and 400 students do not. So what is the probability that a randomly selected student owns a cell phone? Well, if there are 2,000 students and 1,400 have a cell phone, that means that the probability of a student having a cell phone is 0.7. And what's the probability that a randomly selected student owns both a cell phone and a tablet? Well, there are 800 that have both out of the 2,000 students, so that is 0.4. If a randomly selected student owns a cell phone, what is the probability that they also own a tablet? Well, there are 1,400 students that own a cell phone, and 800 of those students have both. That means that the probability of a student who has a cell phone having a tablet is 0.57. Let's take a closer look at this probability and examine the formula that can be used to find the probability of T given C. The probability of T given C equals the probability of T and C divided by the probability of C. Since we already have the probability of T and C and the probability of C, let's go ahead and quickly work out this division to see if it matches our 0.57. So the probability of T and C divided by the probability of C is 800 over 2,000 divided by 1,400 over 2,000. When dividing fractions, we need to change the sign to multiplication and flip our second value. Once we multiply, we have 800 over 1,400, which is equivalent to what we had already calculated. Question D from this lesson asks what the difference is between question B and question C. Question B was finding a joint probability where we were trying to find the intersection of T and C. So out of all 2,000 students, how many had both a tablet and a cell phone? Question C, however, is a conditional probability. So we were only looking at those that had a cell phone. So the probability that they had a tablet given that they had a cell phone. So for question B, we're looking at the whole school's population, but for question C, we were only looking at those who had a cell phone. In question E, are the outcomes owns a cell phone and owns a tablet independent? Well, let's look. We know that our ways for checking for independence are one of these two different formulas. Let's start with this first one. The probability of B given A, well, we just found the probability of owning a tablet given that you own a cell phone. We can then quickly calculate the probability of owning a tablet because there are 1,000 students out of the 2,000 students in the school that own a tablet, which is 0.50. Since these values are not the same, the outcomes of own a cell phone and owns a tablet are not independent. The other method would be to check to see if the probability of A and B is equal to the probability of A times the probability of B. We've already calculated the probability of owning a tablet and a cell phone. It was 0.4. Now we just need to calculate the probability of owning a tablet and owning a cell phone and multiply. So the probability of owning a tablet was 1,000 out of 2,000. The probability of owning a cell phone was 1,400 over 2,000. When we multiply those together, we get 0.35. Since these values are not the same, we again can confirm that our two outcomes are not independent because the probability of owning a tablet and cell phone does not equal the probability of owning a tablet times the probability of owning a cell phone. So to recap, we have our two different methods for checking for independence. We also know that the probability of B given A equals the probability of A and B divided by the probability of A. We can manipulate this formula to find the formula for finding the probability of A and B to equal probability of A times the probability of B given A. And this formula will always work to find the probability of A and B, whereas this one over here only works if the events are independent. And then to review our addition rule, probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Alright, that's it for this video. Thank you for watching.